Mankind has long battled with significant worries in regards to our spot in the universe in the fabulous woven artwork of the universe that is continually growing. Whether or not we are the only ones in this huge space or whether there are different types of life tucked away among the stars is one of the most unavoidable of these worries. We have graphed the developments of divine bodies and created elaborate speculations about the idea of the universe as we have looked at the night sky for centuries. In the expectation of finding the secrets that exist in the universe, we have grown progressively modern instruments to investigate the profundities of room. These efforts, which were motivated by our inherent curiosity and the desire to comprehend the entirety of the universe's mysteries, have led to a remarkable journey of discovery. All through ongoing numerous years, our central goal for data has driven us truly near maybe of the principal disclosure all through the whole presence of science, the acknowledgement of life past Earth. Researchers and laypeople alike have been drawn to this potential, which has energized hypotheses and moved innumerable works of science fiction. In any case, as of now, by virtue of the unfathomable capacities of the James Webb Space Telescope, JWST, this enticing potential has begun to come to fruition into this present reality. The main researcher of NASA as of late made a surprising revelation that can possibly adjust our view of the universe and our place in it. Prepare yourself because an extraordinary secret has been revealed by the discovery of life on Proxima b, a faraway world at the edge of our vast cosmic timeline. Since its discovery, the planet Proxima b, which encircles the star Proxima Centauri, has been the subject of intense scrutiny. As one of the closest exoplanets to Earth, it has for a long while been seen as a great opportunity for the mission for extraterrestrial life. The discovery of life on Proxima b marks an important turning point in our understanding of the universe. It is a completely novel discovery. Not only will this discovery have profound effects on how we understand the universe, but it will also have an impact on how space exploration will develop in the years to come and on the fate of humanity as a whole. Cosmologists have long centered around the investigation of exoplanetary airs on the grounds that these climates can reveal insight into the chance of life on different universes. Cosmologists are able to examine the structure of an exoplanet because the star's light passes through the planet's atmosphere when it passes close to its host star. This methodology, known as movement spectroscopy, has been instrumental in revealing the secrets of faraway universes and is one of the fundamental procedures used by the JWST to search for signs of something happening on a deeper level. The disclosure of life on Proxima b is an exhibit of the power of this technique and elements the phenomenal limits of the JWST. The James Webb Space Telescope is actually a marvel of current science and planning. It is a showing of human imagination and our relentless desire to research the neglected world. The JWST has changed how we see the universe thanks to its cutting-edge technology and unique space vantage point. It has given us a striking point of view on the universe, allowing specialists to focus in on distant immense planets, and stars and habits that were at that point unimaginable. We now have an unparalleled window into the universe thanks to the JWST, which is outfitted with the technology necessary to make these observations a reality. This isn't just a bunch of exaggerated claims. One of the most extraordinary features of the JWST is its fundamental mirror, which gauges a dumbfounding 6.5 meters in broadness. This mirror is more than twice as big as the primary mirror on the Hubble Space Telescope, which has been one of the most important tools for space exploration recently. The JWST's mirror is enormous to the point that it can get even the smallest spots of light from the farthest reaches of the universe, uncovering components that have been challenging to read up for quite a while. Researchers are able to finally see the minute details they've been imagining for a very long time thanks to this enormous mirror, pushing the boundaries of what we know about the universe. Nevertheless, the JWST's abilities loosen up quite far past its enormous mirror. The telescope also houses a collection of cutting-edge instruments that are capable of detecting a wide range of light frequencies. Among these instruments is the Near-Infrared Camera, NIRCam, an extraordinary resource expected to get pictures in the nearby infrared district of the electromagnetic reach. Because close infrared light can penetrate dust mists that block visible light, this location of light is especially important for stargazers because it allows us to see further into the enormous depths of the room. With NIRCam's high-resolution imaging capabilities, astronomers can get an unparalleled look at how stars and galaxies form. This amazing instrument has a couple of fundamental targets. including focusing on the early universe and its by and large old light, breaking down the turn of events and headway of enormous frameworks, and recognizing and depicting exoplanets. Researchers are presently ready to see how enormous scope grandiose frameworks foster over the long haul thanks to the inside and out pictures taken by NIRCam, which uncover designs and subtleties recently concealed by telescopes. As a result, we now have a better understanding of the occult cycles that shape our local astronomy and the history of the universe. Nevertheless, the JWST's NIRCam is just one of many instruments. Another essential instrument on board the telescope is the Near-Infrared Spectrograph, NIRSpec. NIRSpec brings the study of stars and galaxies to new heights by separating the light emitted by them into their component colors or frequencies. This essential technique, spectroscopy, reveals the object's formation, temperature, and chemical composition. Researchers can distinguish the parts of a star or gas cloud by looking at the lines of ingestion and outflow of light, uncovering the essential parts of our universe. Spectroscopy is an incomprehensibly vital resource that overhauls stargazers' ability to examine the convoluted tasks of stars and frameworks. It gives researchers careful pieces of information into the presence examples of stars, the course of action of universes, and the astounding interchanges between these sublime bodies. In addition, NIRSpec plays a crucial role in the study of distant, high-redshift systems, worlds whose light has traveled billions of years to reach us and provides a brief glimpse into the origins of the universe. Stargazers can gain an understanding of these far-off worlds' compound arrangement, age, and other characteristics by examining their spectra, providing insight into the overall development of systems throughout vast history. One more huge progression in our understanding of the universe is the JWST's capacity to research the mid-infrared range. The JWST's mid-infrared instrument MIRI was specifically designed to investigate objects emitting infrared radiation at higher frequencies. From the development of stars to the discovery of exoplanet environments, this capacity empowers specialists to examine different peculiarities. One of MIRI's fundamental goals is to focus on the dusty regions where stars are considered. Infrared radiation can enter these thick buildup fogs, allowing MIRI to glance through the colossal duskiness and witness the presentation of stars and planetary structures. MIRI gets low-down pictures and spectra in the mid-infrared reach, offering space specialists fundamental encounters into the cycles occurring inside these sublime nurseries. Regardless, MIRI's abilities don't stop there. The instrument also contributes significantly to the search for and characterization of exoplanets. By finding in the mid-infrared, MIRI can recognize and analyze the feeble warm surges of exoplanet conditions. The structure, temperature, and qualities of exoplanets, including their possible livability, can now be concentrated on in new ways on account of this ability. MIRI's discernments are vital for concluding the presence of key iotas like water rage, carbon dioxide, and various parts that could show the conditions significant until the end of time. These parts are key for supporting life, all things considered, and MIRI's ability to distinguish them is a particular benefit in the mission for extraterrestrial life. The perceptions made by MIRI are just the start of the James Webb Space Telescope's quest for indications of something going on under the surface. Two of the fundamental methods it uses to perceive life are spectroscopy and travel insights, the two of which lie at the focal point of its focal objective. As previously mentioned, spectroscopy enables researchers to determine an object's structure by examining the light it emits or absorbs. Spectroscopy makes it easier for us to decipher the atomic secrets hidden within the air of exoplanets. The JWST energetically expects travel events, where an exoplanet passes before its host star as per our perspective. When this happens, the telescope can see the starlight separating from the exoplanet's surroundings. The JWST, equipped with high-quality instruments, catches this crucial light. NIRSpec succeeds in the close infrared range, while MIRI takes charge of the mid-infrared range. For in-depth exploration, these instruments work together to create a dynamic duo that spans a wide frequency range. In any case, why is it such a joke to see stars while traveling? The data this light conveys is the response. The communication of starlight with the different particles in an exoplanet's climate brings about unambiguous fingerprints or subatomic marks on the light. Utilizing its spectroscopic abilities, The JWST then cautiously analyzes this separated light to recognize the particular atoms in the climate of the exoplanet. Each molecule has a remarkable course of action of ridiculous features, so by taking a gander at the maintenance or release lines in the light reach, specialists can choose the formation of the environment. The initial step is to figure out which particles are available. The journey for signs of something happening on a deeper level requires a more nuanced approach, as specialists look for particles contemplated biomarkers, substances that could be connected with life. Gases like oxygen, methane, and water fume, which are fundamental for supporting life on the planet, could be one of these biomarkers. In any case, to decide if an exoplanet is tenable all in all and to search for indications of organic action, extra information are required. The JWST involves extra observational procedures notwithstanding its spectroscopic abilities to improve the quest forever. For example, it can perform direct imaging of exoplanets using major areas of strength for its getting unequivocal pictures and gathering additional data about these distant universes. Besides, the JWST can coordinate time series discernments, where it at least a time or two notification an exoplanet all through a time span to follow changes in its environment or distinguish the presence of periodic assortments. These additional insights give a greater picture of the exoplanet's ongoing situation and anticipated reasonableness. They also add to the growing body of knowledge that will be used to direct future missions, such as the development of next-generation telescopes for more in-depth studies of exoplanets. By virtue of Proxima b, the JWST's insights have without a doubt borne regular item. The area of life on this distant world tends to a defining moment in our excursion to sort out the universe and our place inside it. The implications of this discovery are significant, and seasoned researchers are just beginning to grapple with how it affects the future of room research and our understanding of the true capacity of life beyond Earth. As we recognize this striking achievement, we ought to in like manner recall that it is just the beginning. The discovery of life on Proxima b raises as many questions as it answers, so it makes sense to move on to further research and discovery. With the JWST at the actual front of this trip, humankind stays close to the unstable edge of one more time of understanding, one in which we may finally open the insider realities of the universe and uncover the full level of its mysteries. The disclosure of life on Proxima b has opened up one more world as we kept searching for data and understanding, and the JWST is prepared to lead the way. As we center around the stars, we should rest assured that the JWST will continue to stretch the boundaries of what we know and energize individuals coming down the line for specialists, swashbucklers, and visionaries. Overall, the James Webb Space Telescope has opened up a new era of vast research, altering our understanding of the universe and our place in it. The disclosure of life on Proxima b is an exhibit of the power of human interest and the astounding limits of this vital telescope. We should rest assured that the JWST will keep on being at the front of our mission to tackle the most essential inquiries concerning our reality and the universe we call home as we proceed with our excursion of revelation.